Number 3, a sodium vapor lamp emits light photons with a wavelength of 5.89 times 10 to the negative 7th meters. What is the energy of these photons? Now remember, the point of this worksheet is to compartmentalize things you know versus things you don't know, because there are certainly things that you know, even if you don't know some things. For example, a sodium vapor lamp. You don't have to know what that is. Not at all. All you need to recognize is this problem is giving you a wavelength, and it wants energy. Okay? It gives you wavelength and wants energy. Now, if we go up here and look at our useful equations, we have 2 of them to choose from. Now, only one of the equations actually uses the term wavelength. Right? Wavelength is represented by this Greek letter lambda. Only one equation has lambda in it. And it's not the equation that uses energy. Remember, the question is asking for energy, so our final answer needs to be energy. So I need to be able to use this equation. Well, I can't use this equation with wavelength, but I can plug wavelength into this equation and solve for frequency, because I can plug that same frequency into this equation and then solve for energy. So again, over here in the problem solving strategy, if your known is wavelength and the unknown is energy, notice that this is a 2-step problem. We're going to use this first equation right there. We're going to solve for frequency. That's why it's rearranged like that. We'll get frequency. Then we can plug that frequency into this equation and solve for energy. So let's do that. So I have that first equation. Now I need to solve it for frequency, which is this value right here. So I rearrange this equation by dividing both sides of the equal sign by lambda to get the frequency by itself. So frequency is equal to the speed of light divided by the wavelength. Well, the speed of light is always the same value. If you forgot what it is, it's printed up here. 3.00 times 10 to the 8th meters per second. The wavelength was given to you by the problem, 5.89 times 10 to the negative 7th meters. We're going to plug that in on the denominator and plug and chug. Now, if you do your proper work with the division function and with your exponents, dividing the exponents, you'll end up with 5.09 times 10 to the 14th per seconds, which sounds about right because this is frequency. It should be a per second. Now, remember, when you are dividing numbers with exponents, you subtract them. So it's 8 minus negative 7. That will bring you up to 15. Notice this answer isn't 15 because this, coming out of your calculator, ends up being less than 1, right? 3 divided by almost 6. That comes out to be less than 1. So I have to move the decimal from right here over 1, right? And so I have to change this exponent to 14. But now, this is not your final answer. This is the frequency that I can then plug in to this equation right here as this nu. So E is equal to h nu. So down here, E is equal to h nu. H is Planck's constant, right? It's always this. This doesn't change. It's the same number that I've used in the other equations. And then the frequency is the number that I just calculated. Plug it right in there and multiply these two values together to yield 3.37 times 10 to the negative 19th joules.